Hello, and welcome to another Oki Solo Channel YouTube video. So today I wanted to talk about media depictions of dinosaurs and how I go about evaluating how accurate I think they are. And I actually decided that I thought it would be a lot more fun if I not only explained to you the evidence available to me, but also how I came about finding it and interpreting it. And so I couldn't think of a more fun way to visualize it than a conspiracy board. So we're going to start off here because this is the Albertosaurus depiction in the, I guess I'll call it the reboot of Walking with Dinosaurs. And there's an episode where it depicts an Albertosaurus female living in a group setting with complex social dynamics, including a hierarchy, including a matriarch, and cooperative hunting. So I'll admit that I start off all of my reading on basically any topic on Wikipedia for a myriad of reasons, including but not limited to it's fast, it's quick, and it's easy. And the nice thing is that the editing process is actually pretty stringent, and editors have to include citations, and those citations are a wealth of potential primary literature sources for any person interested into delving into a topic. So it appears that all of the foundation of the idea that Albertosaurus could be living in social groups comes from the dry island bonebed, and this is not the dry island bonebed. I'm sad to admit. I couldn't find a picture of the dry island bonebed, so I had to settle for a different one. I think this is the Cloyd-Leveland dinosaur quarry. I just wanted a picture of a bone bed. But depending on who you ask, you'll get an answer of this bone bed includes at least 12 individuals and up to 26 individuals. And that feels like a pretty big range until you know how bone beds and fossilization works, or at least familiar with it. In this case, think of it as figuring out what a fossil is you're putting together a jigsaw puzzle, except most of the jigsaw puzzles you find only have half the jigsaw puzzle. And in this case, it's in a bone bed, which means that it's in a pile with a bunch of other jigsaw puzzles, and all of those jigsaw puzzles are only half there too. And you have to sort through that entire pile of jigsaw puzzle pieces and figure out how many jigsaw puzzles you think are in that pile. All to say, I don't envy anyone who does that for a career. So I guess the first step here is trying to figure out, do we have a group? And so this is actually different age classes. And at this point, I'm not convinced that we do for a couple reasons. One, we are underrepresented in the juvenile class if we're expecting this to be a group setting in which they're rearing offspring. Think of like wolves, where it's typically like 2 breeders, usually like 1 to like 4 helpers, and then however many young they have in that year. There are exceptions, obviously, but this is not the age class range we would expect. And you could counter and say that like maybe the juveniles are underrepresented just because they didn't fossilize, but I will say that bullet point leads to just an inconclusive answer. And so I actually went this way because, believe it or not, there are bone beds out there that, actually the Cleveland bone bed, where it includes Allosaurus, and we have a pretty good idea of what caused the bone bed there to form the way that it did. The best evidence we have is that the Cleveland Lloyd dinosaur quarry is actually the result of drought, and we have a pretty good idea of that because towards the bottom of the quarry we see animals represented in the ratios that they are represented everywhere else. So that means everything's normal. And then as you get higher up in the bone bed, meaning the newer layers in it, the herbivores start disappearing, and then the juveniles start disappearing. And the highest level of the bone bed are a large adult Allosaurus, which indicates that they were the last survivors because they were the biggest, meanest ones around. And you can actually go through, and I will admit I'm not an expert in stratigraphy, so I'm all the more willing to defer to people who are. But from, I think it's Eberth et al., they seem to think that the dry island dinosaur bed formed in under a year and was the result of flooding. And a lot of these bones actually accumulated on top of each other because they were getting caught in log jams and stuff like that. And that's really interesting. So this may or may not represent a group. I'm going to say I don't think it does, but we can't eliminate the possibilities. So the next thought train you can go down is, can we find representation of how this works today? Can we draw parallels? And so I can just got a picture of wolves because they're cooperative hunters. So there's this thing called phylogenetic bracketing. And phylogenetic bracketing is the idea that if you know what a more ancestral state is and you know what a more derived state is, often the most parsimonious answer, meaning the answer with the fewest steps, is that they have a shared commonality. A great example of that is, so this is a quick one I drew of archosaurs, and it includes, let me make sure I got this right, crocodilians and non-avian dinosaurs and avian dinosaurs. So avian dinosaurs are also known as birds, and we have crocodiles today. And a great example of how we can try to use phylogenetic bracketing to kind of draw a parallel is, for example, let's talk about parental care. Hint, hint, nudge, nudge for a future topic video that I'll be doing in a similar format to this. So crocodilians show parental care in a nest, and birds show parental care in a nest. So it's pretty parsimonious to assume that dinosaurs would show parental care around a nest. So what do we know about group hunting, group social dynamics in crocodiles and birds today? Crocodiles are more of a mob hunter. So mob hunting would be if they're in a group setting at all, think Nile crocodiles. They're not necessarily cooperative hunting, in so much that they're hunting in the same place at time, often ganging up on one individual. And that makes sense, because if more than one individual is attacking the same thing, that thing is less likely to get away. But they're not necessarily like in the episode of Walking with Dinosaurs, the female Albertosaurus flushes and purposely herds, I think it was a Maiasaura, towards the larger matriarch Albertosaurus, with the intent of the larger matriarch is more capable of dispatching this prey item, but she's not as fast as the smaller individual is. So that's very different than mob hunting. We actually have almost zero evidence of cooperative hunting in birds too. I actually included a really cool, and I'll include a paper in the description below. Harris hawks actually show evidence of true cooperative hunting, where they'll even they're capable of relay race chasing something. They'll take on different roles within the hunting. So yeah, okay, birds are capable of group hunting, but it's not very common. There's thousands of species of birds, and I could find one for sure case of cooperative hunting behavior. So inconclusive in that result. So I went back to the beginning, all the way back, because if you haven't noticed, this entire side of the board kind of went nowhere for me. And that's part of why I wanted to walk you through all of it, because that's kind of what science is sometimes. You go down many avenues and you lead into a bunch of dead ends, and you just kind of have to deal with it. So in this section, I actually remembered a paper, and I will flash the authors across the screen because I think it's Frederickson et al. 2020, I think. I just checked my notes. It is Frederickson et al. 2020. It was this really cool paper that actually looked at isotopes. So you can look at stable isotopes in organisms because these stable isotopes are... I don't really want to get into the chemistry of it, but the idea here is that different isotopes are found in different parts of the ecosystem because plants utilize different types of carbon. I'm way oversimplifying this, I know that. But plants use different types of carbon. And so that means that animals that eat particular type of plants have different ratios of those carbons. And I'll say stable isotopes because it's not just carbon, but stable isotopes. It's all because plants have different chemistries. And animals that eat those animals will have different isotopes because they were eating animals with different isotopes. So all that to say is you can use these isotopes to try and figure out where something is eating in the food chain, or at least connect the dots. And this was, me personally, this paper very much completely blasted a hole in the side of the ship that Deinonychus were group hunters, because they actually showed that individuals at different age classes had different stable isotope profiles, which indicates that individuals in different age classes were predating on different types of organisms, which is a really big deal because if they were in a pack hunting or they were group rearing individuals for long periods of time, you would expect that the juveniles would have the same isotope profiles as the adults because the adults would be feeding the juveniles for extended periods of time. So then the question is, did I find any papers with Albertosaurus stable isotope profiles? I did not. But I found the next best thing because in trying to find that, I found Theropoda et al. 2021. And this was a paper that was looking at jaw morphology and tooth wear analysis of Albertosaurus at different age classes. And that's pretty cool because what they actually showed was that Albertosaurus had the same type of tooth wear, the same type of jaw strains, XYZ. And think it through, that actually indicates that the age classes are at the very least not mixing, because in order to have those near identical jaw strains and tooth wears, that means that Albertosauruses within their respective age classes are eating prey items and engaging with them in similar battles. So they're experiencing the same kind of strain. It's different age classes. So that means that a juvenile Albertosaurus is probably hunting things that are comparable to its own size, or at least the prey items, and then the adults are eating comparably sized prey items for their own sizes. They're not sharing food between the age classes. And what's even cooler is Theropoda et al. 2023 found a Gorgosaurus juvenile with prey items in its stomach, and the prey items in its stomach were juvenile. Let me look this up real quick. Okay, just want to make sure I had it right. It had 2 juvenile dinosaur in its stomach cavity, which means that these were items that most likely were hunted by the Gorgosaurus itself. And so you're like, okay, you jumped from Albertosaurus to Gorgosaurus. I did. Also, Albertosaurus and Gorgosaurus are considered sister genera, to the point where some authors have actually argued that Gorgosaurus is actually a type of Albertosaurus. So I didn't find isotope analysis on Albertosaurus. I found tooth-wear analysis of Albertosaurus that indicated that they're hunting within their own size range, and I found a related species of Tyrannosaurid, Gorgosaurus, with a juvenile that had evidence that it was hunting things within its own size range. So, looking at this board and walking through all of this evidence, what's my opinion? I don't think it's impossible that they could be living in a group setting, and I don't think it's impossible that they could be cooperative hunters. I just think it's very unlikely given how rare it is in the modern world. And also, we have a lot of evidence that indicates that they were not living in a group setting, or at least they were not having extended child rearing. I mentioned and alluded to earlier, I think it's entirely possible and indeed incredibly likely that they had nest rearing of juveniles in the infancy stage, but I just don't think we have the evidence for extended group rearing and cooperative hunting. We don't have evidence of trackways of them walking alongside each other. We get scant little evidence, and that's really what I wanted to drive home here, is that we have so little evidence to work on in behaviors of animals. We know so much about what prehistoric animals looked like and how they moved and stuff like that, but we don't necessarily know what they were doing, and that's resulted in some really cool ways people have tried to figure out or guess to where these animals might be capable of doing, ranging from phylogenetic bracketing, comparing with modern relatives, isotope analyses, tooth wear analysis, and sometimes you just get really lucky and you find a juvenile individual with the stomach contents still intact of its last few meals. So yeah, I really hope that's really enlightening to how you can go about trying to figure out what are scientists looking at when you're looking at media depictions. How are they speculating, and how are they trying to depict reality? And when is it sometimes just cool, and when is it sometimes not? This will not be the first time I'm looking at media depictions of dinosaurs, because they're just fun, and I think it'll allow us to have more discussions around how these animals may have lived and the evidence around what they were doing and how people are trying to figure that out. If you have any particular questions, comments, concerns, please put them in the comments section. I also would say that if you think this video is cool, please comment, and subscribe. That actually tells the algorithm that I did a good job, and it will recommend this video to other people who may or may not be interested in this particular topic. But until next time, I'd say stay curious and maybe read a few papers on dinosaur science.